Okay, moving on, let's look at factorizing. Now, in the last lesson, we looked at factorizing a question like this, where you're just pulling out the common features and it's now in its factorized form. Let's extend this in this lesson into factorizing via the decomposition method. We might have a look at the Australian method, and then we can finish off with completing the square. Now, um, completing the square would have been taught last year, so would have probably the decomposition method. And then some schools may have looked at the Australian method, others might not have. So usually you kind of stick to just two methods, either the decomposition and completing the square, or maybe the Australian method and completing the square. You only really need two methods to be able to do everything that you need to do. Okay, let's say you want to factorize this quadratic equation. There's a few things we have to note first. So we have to look at the coefficients and understand what a coefficient is. So it's the numbers um, in front of either the x squareds or the numbers by themselves. So we have um, 20, -7, and -3 as our coefficients. And normally this quadratic is written in the form ax squared plus bx plus c. And so our A coefficient would be 20, our B coefficient would be -7, and our C coefficient would be -3. Even if this equation is written in the form of -7x plus 20x squared minus 3, I would highly suggest rewriting it back into this ax squared plus bx plus c order, because your A coefficient is always going to be the coefficient in front of the x squared. Your B is always going to be the one in front of x to the power of 1, and your C is always going to be the independent. Now, the reason this order matters is because with our first factorization technique, we're going to look at, for instance, the decomposition technique, where we need to know what our A and C coefficients are. So for this technique, we take our A coefficient, we multiply it by the C coefficient, and from that we get a number, and then we look at the factors of that number that will add to the middle term. So for instance, our A times by C in this case is 20 times by 3. Now, when using this technique, we don't care whether the numbers are positive or negative in terms of the A and the C. We're just after the absolute values. So even though the coefficient for C is -3, we're just going to use a +3 for this one. So I might write it as the magnitudes of A times the magnitudes of C. So that's equal to 60. Now, let's try and find the factors of 60 that add to the middle term -7. So what do I mean by factors of 60? Well, 60 times by 1 is 60. So that's one set of factors. And you could go through and try and guess what some of the other ones are. But another technique would be, well, you could divide this one by 2. So you times this one by 2. So 60 divided by 2 gives you 30. 1 times by 2 gives you 2. Well, 30 times by 2 is another set of factors that add to 60. So this technique of dividing and timesing by that same number doesn't have to be 2, could be 3, 4, whatever, is a fast approach to find out other factors. So I could keep going. I could go 15 times by 4. Well, that's also 60. Um, and then if I keep going, it's just going to hit these ones in reverse. So there's 3 from this technique. But I could, instead of dividing by 2 from here, I could have divided by 3. So I could go 20 times by 3. Still gives me 60. Now that one was a little bit obvious because that's my A and C values. Now, as I'm going through these and I'm trying to find the factors, I'm trying to find factors that will add to -7. So that could be the sum or the difference of the two terms. So if we keep going with this 20 and 3, well, you could divide and times by 2 again. So you could have 10 by 6 gives you 60. You could have 5 by 12, still gives you 60. Now this one here, 5 and 12, the difference of those two is 7. So we're after a -7, so we might use a +5 and a -12 to get to -7. So let me rewrite this on the next page. Okay, so I've rewritten it on a new page. I've got my quadratic, my A and C, 20 times by 3 gives me 60. And I found that a set of factors for 60 are 5 and 12 that add to -7. So I've got a -12x plus 5x minus 3. So because it's a 7x in the middle term, I don't want to change the value. I just want to change the representation. So 12x minus 5x, sorry, minus 12x plus 5x is -7x. So I haven't changed its value, just its representation. Now, I've decomposed this into two terms. Um, what I want to do now is I want to find a common factor of the first two and a common factor of the second two. So I'm trying to now factorize this. If this is a funnel, I'll get factorized out of the first two, factorized out of the second two, with an addition between the two things, and then I'm going to have a completely factorized form at the end in the final step. Now, when you're doing the decomposition method, the order of these two don't matter. So you could have had plus 5x minus 12x and still done the factorizing of the first two, factorizing of the second two. You'll get to the same answer at the end. Now, in saying this factorization technique, you have to be careful. On occasion, there are two sets of factors that work, but only one set of factors will actually work in the decomposition and refactorizing method. So I'll go over a question after this one that shows an example where that will pop up, just because a lot of schools skim over this content so quickly that you don't really get to see examples where it doesn't work. Now, if we continue this, so what are the common factors in the first two terms? So you can draw an imaginary line if you needed to. Now they're both even, so we could pull out 2 of each one, but we could probably go a bit higher. We could probably pull out 4 of each one. We go 4 and x is also common. So pulling 4x out of this first term, we're left with 5x. Pulling 4x out of the second term, we're left with -3. Now, when we're pulling stuff out of the second two terms, we want it to be very similar, well, exactly the same as this bracketed stuff. So what will give us 5x minus 3? We don't actually have to pull anything out. We're going to get that anyway. So we're pulling out effectively 1, a positive 1. We're left with 5x minus 3. And then we look at what's common. So we're at this step here now in the funnel. Now we're looking at what's common. Well, we have a 5x minus 3 that's common to both of these terms. So we pull that out. And we're left with 4x plus 1. So 4x was left out of that term, plus 1 was left out of that one. So that is the decomposition method. Now I'll show you the decomposition method one more time with an example where you have more than one factor that can pop up. So let's look at this quadratic equation. It's already in the form ax squared plus bx plus c. Now our a coefficient is the one in front of the x squared term, so a is equal to 1. And our c coefficient is the one that's independent of x, so c is equal to 6. Now we're going a times by c, so 1 times by 6 is what we're looking for the factors of that add to 5. Now we can already see one factor is going to combine in such a way that it adds to 5, but you've got another factor in this case. You've got 2 times by 3 is equal to 6. That's another factor that'll add to 5. So only one of these factors is going to work. And usually when you're finding your A times by C and you're looking for the factors, you'll only have one factor that will work. Sorry, you'll only have one factor that's available to plug in this decomposition method. But on occasion, you do get more. And again, only one of these is going to work. So let's look at this one first, this 2 times by 3. So let's break up 5x into 2x plus 3x. Again, doesn't matter if it's 3x plus 2x or 2x plus 3x. Your answers are still going to be the same. Now, with this, remember we're effectively drawing an imaginary line and factorizing the first two terms and the second two terms. So the first two, we have x that's common. So we have x plus 2 remaining. And in the second two terms, we could pull out a 3 to have x plus 2 remaining. So plus 3, x plus 2. So that'll give you 3x plus 6. Yep, so you got x plus 2, and you have the same thing in the brackets in both cases. So you're pulling out x plus 2 next. So you have x plus 2. Out of this first term, you have an x left over. And out of the second term, you have a 3 left over. And that is your factorized form of that question. Now, we saw that we actually had another option to choose from. So 6 minus 1 will also give us 5. So we could have broken, so if I rewrite the question, x squared plus 5x plus 6, we could have broken that 5x into 6x minus 1x. And it's still valid. So in this one, again, drawing the imaginary line down the middle, common feature between the first two terms is x. We have x plus 6 remaining. And in the last two terms, we want to get it to x plus 6. Now, if I just write over to the side here, so minus x plus 6, we could pull out option 1, we could pull out 1 and have it as minus x plus 6. But that's not exactly the same. In this case, we have a minus x instead of a positive x. An alternative approach is we pull out negative 1 and would have a positive x, but a minus 6. Again, it's not the same. So it's not going to work because you're not going to have the same set of brackets that you can pull out of each term in that next step. When you're doing this, you do actually have to pay attention to what you're pulling out because it's very easy to put in a 6 and a minus 1 and then think that you're going to get an x plus 6 in both terms. Okay, one more example before I get you to try this yourself is in the last lesson, we saw that when we were expanding this, we got this quadratic, but I was saying that this quadratic could also be factorized into this form here. Now, I showed you the working quickly, but I didn't explain what was going on. So going through it, we have 12 times by 4 gives us 48. Factors of 48 that add to 22 would be 24 and 2. So 24 minus 2. So we're looking at the difference between those two factors. We then factorize the first two terms. So you have a 12x that's common in those first two terms. And to get an x plus, so leaving behind an x plus 2. So to get that in the second two terms, we want to sub out or factorize out a negative 2 to get a positive x plus 2. And then we're factorizing out x plus 2, leaving behind a 12x and a minus 2. But then in this one here, we also have even and even. So that can be factorized even further. So we can pull a 2 out of that, bringing it as, making it 6x minus 1. Okay, I've written out another quadratic here. I want you to have a go at factorizing this quadratic using the decomposition method that we just went through. So pause the video here and I'll come back in a few seconds. Okay, with this, there are two techniques that you could have done. in terms of using this decomposition method. Now, I'll go over the one that you're likely to do first, just because we haven't really touched on the second just yet. So your A value is 2, your C value is 28. So your A by C is 2 by 28, which is 56. Now, what are the factors of 56 that add to 18? So you have 1 by 56, 2 by 25, 28. You have 4 by 14. So I'm using that times by 2, divide by 2, times by 2, divide by 2, just to try and find those factors relatively quickly instead of plugging around on a calculator, or if this was tech free, fiddling around trying to do a whole bunch of multiplication math on the side. So 4 by 14 adds to 18. Now, this may not work, and there could be a potential another option. But what you normally do is the first time you find a set of factors that work, you use that to plug that in. So hopefully this works, and you also use the 4 and the 14. So let's keep going. 2x squared minus 14x minus 4x plus 28. Again, the order of the 14 and the 4 doesn't matter. It's just 14 plus 4 gives us 18, and they're both negative because we want to add it to negative 18. Now, you draw your imaginary line. You don't actually have to draw it. It's just a visual aid while we're still learning. So we've got the first two terms. What's common? Well, we have a 2x that's common. Left, and so if you did order this the other way around, what you're pulling out might be different, but again, it's just the end result that should be the same. So pulling out 2x leaves behind x minus 7, and we want x minus 7, so we'd have to pull out a negative 4 to get positive x, leaving behind x, and pulling out negative 4, we do get a negative 7 out of that 28. Awesome. So this was a 4 and 14 was a set of factors that worked. We have 2x minus 4, so pulling out x minus 7 from each term. We're left with a 2x remaining and a minus 4 remaining. Now, is this your final form? Not quite. So you have an even value and an even value. So we can pull out another 2 out of this first term. So pulling 2 out of the set of brackets leaves behind an x minus 2, x minus 7. And when we're pulling it out, we're only having to pull it out of one of those set of brackets, because when you multiply it back in, you're only multiplying it into one of those set of brackets. And that would be our end answer for that question. Now, I said there was another approach. The other approach is just a change to the very first step. So instead of diving straight into A times by C, we can see if there are common factors out of all three terms within the quadratic to pull that out to simplify the math for the rest of the question. So we see that there's 2x squared, there's an 18x, and there's 28. They're all even. So we can pull out at least 2. So we're pulling out 2, leaving behind x squared minus 9x plus 14. Now, we have that 2 out the front. We know that we're going to end up with a 2 anyway. So we've already factorized out that 2. And then the remaining stuff is going to create those next 2 sets of brackets. So in this situation, our A value is equal to 1, because you have 1 in front of that x squared, and our C value is equal to 14. So A times C equals 14. What are the factors of 14 that add to 9? So you have 1 and 14, 2 and 7. So again, times by 2, divide by 2. So the 2 and 7 work. That adds to 9. So we have 2 x squared. So rewriting everything except this middle term is going to be decomposed into a negative 7x minus 2x plus 14. 2, pulling out a common term in that first two brackets is x, left behind a x minus 7. And then in the second two terms, to get a positive x, because we want a positive x, I'm going to have to pull out negative 2. We get x minus 7 again. Awesome, things are looking as they should. And so factorizing out the x minus 7 next. Left behind an x and a negative 2. Now, because all of this is multiplied together, you don't actually need this large square set of brackets anymore. It's unnecessary. So we just write it as 2x minus 7, x minus 2. And we see we got the exact same thing. Again, order doesn't matter because it's multiplication. A times B times C is the same as A times C times B. So all three terms are still the same. Okay, last one for this video. I've got another quadratic written out here. Now, instead of it being x squareds, we've got y squareds, but it just means that the variable in this quadratic is y instead of x. But it is still a quadratic with it of the form ax squared plus bx plus c. So factorize this quadratic, give it a go. Use the decomposition method that we've been going over, and I'll come back in a few seconds. Okay, hopefully you had paused the video and given it a go. So we could either go A times by C and find that middle term that we're then looking for the factors of. But we can see also that we have 3, which is common to each one of these terms. So we can make it easier on ourselves by reducing the size of these numbers by factorizing 3 out first. So if you didn't do the factorizing of the 3 out first, you should still have a 3 factorized out of your other brackets in your final answer when you did the other approach. So factorizing out, we have y squared minus 4y minus 12. Now, our a value is 1, our c value is 12. So a by c equals 12. Sorry, again, our c value is negative 12, but we're using absolute values for this. Now you can see that trying to find the factors of 12 that add to 4 is again easier than trying to find the factors of what 3 times by 36. So what's that, like 108? Find factors of 108 that add to 12. So the factors of 12, you have 1 and 12, 2 and 6. 2 and 6 work. So we could break up 4 as negative 6, positive 2, because we want it to be still a negative number. So the larger number will hold the negative. So rewriting this and then decomposing the middle term into negative 6y plus 2y minus 12. And then we're breaking up this into the first two terms and the second two terms. So what's common in those first two terms? Well, we have a y. And then what's common in the second two terms? Well, we want to get it to y minus 6. So let's pull out 2. And we do indeed get y minus 6. Now, in the next step, I'm going to factorize the middle stuff again. So I'm also going to just get rid of these square brackets because they won't be necessary. Now, if I'm pulling out y minus 6 of each of these two terms, I'll be left behind with a y from this first term and a positive 2 from this second term. So this should factorize into 3, and then one of your second set of brackets should be a y minus 6, and another set of brackets should be y plus 2. And we'll leave it there for this video. And then in the next video, we will look at the Australian method for factorizing and then also completing the square.